Hi there, and welcome back to this channel. In this video, we are going to be talking about how to balance chemical reactions. I want us to know that balancing chemical reactions um, is one of the simplest things that you can ever do. Lay your hands on in chemistry. It is very simple. It is very simple. All right. The only problem people have with it is the method that they adopt. You see, when you adopt the wrong method, the method of guessing numbers to just fit into an equation, you tend to do it wrongly. All right. So, for example, look at this equation. If I were to balance this equation, Na plus NaNO3 to give me NaO plus N2 gas. And if we are to balance this chemical reaction, now some people would say, okay, how many nitrogen do you have there? I have 2. Then I'll come and put 2 here. So it means that these 2 are covered for this guy, 2 sodium, and then 2 nitrogen. Then the oxygen is now 6. So I'll put 6 here. And all of those guessworks. Now, actually, you are going to still go in that way, but you will not be guessing this time. You will not be guessing this time. You understand? So at each step of the way, you are going to see what you will know exactly what you should add rather than guess. All right. So let's go into solving this, balancing these chemical reactions. Now, the first thing you must know is that there is hierarchy. Is that okay? So we always take the metals first, then the non-metals, then that is non-metals now except hydrogen and oxygen. So what happens is this. We have to write the metal first, then non-metal apart from hydrogen and oxygen, then after writing all non-metals apart from those two, then we go to the hydrogen, then oxygen. Now this is the reason. In that hierarchy, we almost always discover that oxygen balances itself out. So because of that, we don't need to alter it so much. So, and it's usually because it ends it's part of the radicals that end most of these compounds. So because of that, it tends to balance itself out. Is that okay? So write it last. You go from metals, non-metals, apart from oxygen and hydrogen, then oxygen. So let's go there. So what you want to do is this. Let's list all the atoms that are reacting here. We have iron is reacting. That's the metal there. Sodium is also a metal here, so we list it. Chlorine is a metal here. And hydrogen is also a metal. Okay, this space is not enough for it. Let's try to manage it. So I have, let me list that again. I said I have iron, sodium, chlorine, hydrogen, and oxygen. All right. Then for this same place, for the second part, this is the backward reaction, this is the forward reaction. Reactant and product. So I have the F, Na, Cl, H, and O. So these are the 5 species that are reacting here, that are involved in the chemical reaction here. Now, how do we go on to balancing? What you first do is this. Write how many of those species you have in the reaction first. How many Fe do we have here? There is no number here, there is no number here. Now notice, another rule is this. After writing this and writing the oxygen last, make sure also that you don't alter these numbers, these subscripts. You cannot alter the subscripts. You can only add to the moles. You can only add moles. And you cannot subtract either too. You can only add, you cannot subtract, and you cannot affect these subscripts. Is that okay? So here now, what do we do? What do we have? How many Fe do we have here? 1 in the entire backward reaction. 1 Fe. Na, 1. Cl, how many do we have? 3. So we have 3 here. Hydrogen, how many do we have? No hydrogen here, 1 hydrogen here. 1. Oxygen, how many do we have? Just 1 here, 1. Is that okay? So I think we are done with all of that. Then we'll come to the other side. How many Fe do we have? Same here, we have 1. Sodium, how many do we have? 1 here, so put 1 here. Chlorine, how many? Still 1 here. Hydrogen, how many do we have here? We have 3, because this is hydroxyl, and hydroxyl is a radical, so these three will belong to both of them. So we have 3 oxygen, 3 hydrogen, and 3 oxygens. So what do we have now? How do we begin to balance? All you have to do is now compare. How many Fe do we have here? 1. Fe1. So Fe is balanced. We don't have to alter it. Sodium 1, sodium 1. It's balanced also. We don't have to alter it. Now, chlorine is 1 here, but chlorine is 3 here. So what do we do? Since it's 3 here and it's 1 there, we'll come and increase here. We cannot reduce. We can only what? Increase. We can only add. We cannot subtract. So this one is more than this. So we add to this to make it equal to this. Now, what do we add? What do we do? We are going to put 3 here to make chlorine become what? 3. But mind you, by putting 3 here, we have altered how many sodium we have in. Now we have how many sodium here? We now have 3 sodium. Notice what I did. I cancelled what we had before, and I put the new number that we have added. So here, I cancelled what we had before, and I put the new number that I added. All right. So sodium now has increased to 3. Here is still 1, isn't it? So what do we do? Let's come on. Now notice I am still part of it. The reason why I came back here is because I've altered the metals. Make sure you balance out the metals before you go to hydrogen and oxygen at all. So I come here. I see that sodium has changed here to 3. So I come here and alter it. I add 3 here. So I alter this place that's changed to 3. Now the only things that are affected here are what? OH, O and H, oxygen and hydrogen, and those are the ones I want to balance last. So let's check again. Fe1, Fe1, chlorine 3, sodium 3, sodium 3. All right. Let's go to the hydrogen. Now, how many hydrogen do we have here? Now we have 3 hydrogens. How many oxygen do we have? 3 oxygen too. Now let's check here. How many hydrogen do we have? Still 3. How many oxygen? Still 3. So you see, hydrogen and oxygen, especially oxygen, balances itself out. All right. Let's go to the next question. This is also simple. Now we have Ca is the metal there. Now, silicon is not a metal, but at least it is electropositive. It is just a solid, but I mean, it is more electropositive than these other substances here, other atoms here. So we are going to write it next. Is that okay? Silicon. And the next one will be potassium. Phosphorus. And the next one will be, the last one will be oxygen. So we have 4 reacting species here. The same way here, CaSi. We must have the same thing. Is that okay on both sides? Phosphorus and oxygen. All right. So we'll come here. How many calciums do we have? We have 3. So we'll put 3 here. How many silicons do we have? No silicon here. We have 1 silicon here. 1. Phosphorus, how many? PO4. This 4 belongs to only O, while this 2, because PO4 is a radical, so they act as a single unit. This 2 belongs to both of them. Is that okay? So 2, phosphorus will be 2 here. And oxygen will be how many? Oxygen will be how many here? We have O4 times 2, that is O8. Then don't forget that there is oxygen here as well. So that 8 plus this 2, it becomes 10. And I think we're done. Now we'll come here. How many calcium have we? 1. How many silicons? 1 still. How many phosphorus? 1. And how many carbon? We have... Okay, I think we missed out something here. So the equation is not complete. This guy is not supposed to be here. So what I'm going to do is, I'll basically alter this. Let's change the question. So let's say this guy was reacting with, H2SO4, for example. So what would happen is we have CaSO4 plus H3PO4. All right. So with this, what do we have now? This is what we have. So how we'll go back to the first step. We're going to have calcium still, phosphorus now, then sulfur, then hydrogen, then oxygen. Is that okay? So we have 5 species now. Calcium is 3. Phosphorus is how many here? 1. Is that okay? 2 because of these 2 outside here. Sulfur is how many here? No sulfur here, so we'll come here. Sulfur is 1 here. Hydrogen is how many here? 2. Oxygen is how many? 4 here plus 4 times 2, 8. 4 plus 8 is what? 12 oxygen. Is that okay? So we write the same thing here. We have calcium, phosphorus. Those are the reacting species I mean now. Phosphorus, sulfur, hydrogen, and oxygen. Now, how many calciums do we have here? 1 calcium. So you have 1. How many phosphorus do we have? 1 here. PO4. Remember this 4 belongs to only the oxygen. Then that's P. And sulfur, 1 still. Then hydrogen, how many do we have? 3 here. And oxygen, how many do we have? 4 plus 4, 8. All right. So let's begin to compare. Calcium is 3 here, while it is 1 here. So what do? We raise this one to 3. So we have what? 3. I'll come and put the 3 here. Now you can always do this one with pencil. You can always do it with a pencil first, so that if you make any mistake, you can easily annul it. So we have 3 here, 3 here. Now 3 calciums. Now let's go to the phosphorus part. We have 2 here and we have 1 here. So what do? We can come and put 2 here. By putting 2 here, phosphorus becomes 2 already. Is that okay? Notice that we are adding these numbers, these moles. They are changing the number of the other atoms there, other species there. But we are less concerned yet. You understand? So we balance according to this hierarchy. So now check. How many sulfur do we have? Sulfur number has changed actually. It has changed from 1 now to 3. And let's check here. How many sulfur do we have? We have what here? 1. So what do? We come and add 3 here. When we add 3 here, sulfur becomes 3. Is that okay? So now, calcium is balanced, phosphorus is balanced, sulfur is balanced. Now hydrogen, let's see. We have 3 there. And let's see how many hydrogen we have here now. 2 times 3 is 6. So we have 6 hydrogen here. And oxygen then has become 4 times 3, 12. 12 plus 8 as 20. Let's see the other side. Hydrogen is 3 times 2, 6. And oxygen is 2 times 4, 8. 8 plus 3 times 4. 12, that's 20. You see? It is balanced. Hydrogen and oxygen almost always balance themselves out. So now you see this reaction is not hard, but if you have solved combustion reaction of alkanes, of hydrocarbons before, especially alkanes, you see that balancing it is not as easy, as seamless as these ones are. So we have C3H8 reacting with oxygen to give us CO2 plus H2O. All right, so what do? We write the reacting species the same way, CH and O. CH and O. Now look at what I am doing carefully. Now we are going to see how many calciums we have, how many carbons we have. We have 3. How many hydrogens? 8. How many oxygen? 2. Very easily spelled out. Calcium 1, carbon 1, hydrogen 2, oxygen 2 plus 1, that's 3. Is that okay? Now, what do? Since the carbon is 3 here and is 1 here, what do? We come and add 3 here so that carbon becomes 3. Is that okay? Now, we have added this guy, carbon has become 3. Now with that, we have changed the number of oxygen, but we are less concerned yet. Let's go to hydrogen. How many hydrogen do we have here? 8. How many hydrogen do we have here? We have 2. So what do we put? We add 4 here. So by adding 4 here, we have what? 8 already. Is that okay? Now, oxygen is yet to balance out. Why? Because it has altered, as the number has been altered here. Here we still have 2. So here, how many do we have altogether? 3 times 2, 6. Plus, how many do we have here? 4 times 1, still 4. So that's 10. Now, 10. So what do we do to make this guy be equal to 10? We add 5 here. Now, if we add 5 here, let's see. This becomes 10. Let's see if all our species are balanced. Carbon is 3, hydrogen is 8, oxygen is 10. All right, let's come here. Carbon is 3, oxygen is, now oxygen is not, carbon is 3, oxygen is 6 plus 4, 10. And hydrogen is 8. Okay, I think it is balanced. All right, but there are other ones that are more complex than this. So, but when you come across them, I don't want you to be scared. Just follow the principle of writing everything, um, first, all the species you have there, and then begin to balance them one after the other, beginning with the metals. Is that okay? If you did gain value from this video, make sure you like the video, subscribe to the channel, and share with others that you think might need the video. See you in the next one. Also, make sure, and if you need other questions, I'm going to drop my WhatsApp number in the description so that you can call me or reach out to me through WhatsApp. And I'm going to send you questions. I have a list of more than 20 questions on balanced chemical equations. I can send them to you via WhatsApp, and you can attempt them on your own. All right, see you next time. Bye.